Today's problem is assign mice holes. Difficulty easy. You are given two arrays, mices and holes of the same size. The array mices represents the positions of the mice on a straight line. I guess you could think of this as like a number line. We'll look at examples of it. While the array holes represents the position of the holes on the same line. Each hole can accommodate exactly one mouse. A mouse can either stay in its current position, move one step to the right, or move one step to the left. Each move takes 1 minute. The task is to assign each mouse to a distinct hole in such a way that the time taken by the last mouse to reach its hole is minimized. Okay? So for example, we have mice at position 4, position -4, and position 2. Again, it's probably best to think of these as being points on a number line. Now there are holes, and again, you can think of these as points on the same number line at 4, 0, and 5. Their suggestion is to assign the mouse at position 4 to position 4. So that takes 0. Now, we're not really concerned with minimizing, well, what am I trying to say? Minimizing individual mice. We are not concerned with minimizing the overall time that it takes for mice to reach the holes, but we are interested in minimizing the maximum time that it takes for a mouse to reach a hole. So the algorithm that we're going to use actually would assign the mouse at -4 to the hole at 0. Okay, so that is 4 minutes. That would take 4 minutes. The 2 would be assigned to the hole at 4. That would take 2 minutes. The 4 would be assigned to the hole at 5. That would take 1 minute. And so the maximum for the last mouse to reach the hole would be 4. In this one, we'll assign the mouse at 1 to the hole at 10 and 2 to 20. It's the best we can do. It's 18 minutes. Okay, constraints. The size of the arrays will be between 1 and 10 to the 5th, 100,000. The numbers in the arrays, the positions, can be between -100,000 and 100,000. Expected complexity n log n. So it looks like there's some sorting going on. And the topic tags. Okay. Sorting, yes. Greedy. Okay. Greedy. Well, the combination of the fact that that the difficulty is easy and a greedy algorithm is suggested makes me think that what we could do is just to sort both of the arrays and then assign the mice to the hole at the corresponding index, because sorting both arrays is essentially matching mice and holes that are going to be relatively close to each other. Okay, so it's a greedy approach. It's not. I guess I would say it's not guaranteed to work. If it doesn't work, I'll have to think of something else and re-record this. But what we're going to do is sort the mice array, sort the holes array. We'll keep track of max in a counter. Max, originally set it to something small, -1. And then iterate through the arrays. match up the mice and the holes at the corresponding index, do a subtraction, take the absolute value. How far is the mouse from the hole? If that result is bigger than the current max, then we'll put it in max. But I would expect, if we do it that way, that we're going to get the result that we want. Let's just try a sanity check here. All right, and then submit. All right, wow, it was fast, but yeah, okay, mice and holes. I mean, the clues there, I guess, were that it's easy. I mean, it did list mathematical as a topic tag. But I think really if you needed to work out some mathematical formula to figure out how to optimize this, it wouldn't be rated easy, okay? And then the greedy algorithm suggests, let's just sort them in a way that is guaranteed to arrange mice and holes that are relatively close to each other. And so yeah, that works. All right. You can like the video. You can subscribe to the channel. It's free. And we'll see you next time.